The next question of lead code biweekly contest 121 is minimum number of operations to make x and y equal.
So in this question, we will be given two numbers x and y, and we can do we have four operations which we can perform. If x is divisible by 11, then we can divide that number by 11. If x is divisible by 5, then we can divide that number by 5. And either we can increment x by 1 or we can decrement x by -1. So at one step, at one operation, we can choose any of these things and perform the operation. And at last, we should make x equal to y. So our task is that we need to find out how many minimum number of operations we need to do so that x will become y. The constraints for this problem are the x and y can be from 1 to 10 to the power of 4.
So the main observation to solve this problem, let's look over the observations that we can make. So the main observation here is firstly, for sure, after at least absolute of x minus y number of operations, we can make x to y, right? That is because we can perform either type 1, either type 3 or type 4 operation all the time. If x is smaller than y, then it's just type 4. Then it's just type 3, that is performing operation where we do x plus 1. Otherwise, we can just perform x is equal to x minus 1 operation. So that is why within these many operations, we can reach it. We can reach x, we can make x to y. Now, our aim is to say if we can make x equal to y with less than absolute of x minus y number of operations. So now if we look at the x limit, x should for sure be greater than 0 because making x negative is useless. And the upper limit of x should be for an optimal way of getting number of minimum number of operations. Absolute range of x can be x less than x plus absolute of x minus y. Right? This is because after performing absolute of x minus y operations, we could make x equal to y. Then if x goes more than x plus absolute of x minus y plus more than or equal to x plus absolute of x minus y, then that means we are performing type 4 operation, type 3, that is x is equal to x plus 1 operation, absolute of x minus y number of times, which is useless for us to perform because we already know we can make it using absolute of x minus y number of operations. And increasing the number of operations is always useless. So this is what our range should be x greater than 0 and x should be less than x plus absolute of x minus 1. Now to solve this, we can't predict, like we can't logically or mathematically calculate at a particular state of x performing which operation would be better. So what we do is we explore all the operations as the range is very small. X plus absolute of x minus y can just be 2 into 10 power 4 from the constraints in the worst case if we observe. So to solve this, we can apply breadth first search. So before this, prerequisite is breadth first search. So if you guys don't know breadth first search, first go learn breadth first search and then come back, watch the video from this point. So basically here what we do is initially our value is x. So we just perform a breadth first search by exploring all the 4 options. So while doing breadth first search, we can observe that the level at which we are, will be the number of operations that we perform till now, right? So initially, this represents the level and this represents the number, the current X value, right? So now, initially, our X value is X and the operations that we performed are 0. Now, from this state, so basically, if we perform breadth first search, we remove the first entry. So for here, the leftmost entry is X comma 0. Okay? So basically, our current X value will be equal to the first one, the first entry. That is the leftmost one. So this will be our X value, and we know what is the level of this, which we stored. Let's say it is X comma level, where the first entry has two things. One is the X and other thing is the current level. So now let's see how we can perform the BFS. Our first criteria is for the current X to be a valid X. X should be greater than 0 and X should be less than X plus absolute of X minus Y. Right? If this don't satisfy, then we can just ignore this X. Otherwise, we can explore the next set of values. So in case we perform operation where we make X is equal to X by 11, for that, firstly, X should be a multiple of 11. This should hold. If this holds, then we can explore the current possibility. We can just push X by 11. Now we can explore the second possibility, which is X is equal to X by 5. If this holds, then we can just push X by 5. We can explore the next possibility, which is this, and we can push X, and then we can explore the other possibility, and then we can push X minus 1. Okay? So here we push X plus 1. So basically we are just performing BFS. Now one more thing is we push X by 11, comma, the current level plus 1, because we are moving to the next level. So here level represents the number of operations that we are performing, right? Comma, level plus 1. Plus 1. Okay. So now, firstly, this set of conditions should satisfy. And we can observe one more thing, that we might explore X multiple times, but we just need the first time that we explore, right? If X is already visited, and we only explore it if X is not visited. Because as we are performing breadth first search, we always visit X with the smallest level possible. So that is why if we visit X for the second time, then we can guarantee that we visited X with either with the minimum possible level or greater than the minimum possible level that we could visit X. Right? We could visit the current updated X from the initial X. So this way we can just perform breadth first search by just exploring all the 4 options. And why is this so fast? Why this will work fast enough is we can observe that X will be in the range 0 to X plus absolute of X minus Y, which is nothing but if we just analyze it based on the constraints, inclusive, let's say. So if we analyze based on the constraints, this could be 0 and this could in the worst case be 2 into 10 power 4 only. So each x we only visit once. So this way we can just calculate the time complexity. As we are visiting each x only once, we can say the time complexity of this would be big O of x plus absolute of x minus 1. So it is just kind of doing standard breadth first search. Now we know that for sure we'll reach y, right? So that is like we'll be reaching y if x is equal to x plus absolute of x minus y. So because we for sure reach y, no, we won't reach y when it is this. Uh, like after performing absolute of x minus y operations, at least we'll for sure reach y. This is what we can guarantee. So that means in case after some point, if x becomes y, we can just return the level. We can just consider the level with which we visited this as our answer. Because the first point when this meets, that will be the smallest level, which is nothing but performing minimum number of operations. Right? So this way we can solve the problem. So we can just restrict x in the range 0 to x plus absolute of x minus y from the above analysis and just perform a standard breadth first search by exploring all the states and maintaining the level. Okay. So if we look at the time complexity, uh, it is big O of x plus absolute of x minus y. This is per test case. And space complexity, we can say it is big O of x plus absolute of x minus y as we maintain a visited array. These two are per test case. So this way we can solve the problem.